Okay, well, thank you for your patience and welcome. And thank you for joining us for the closing panel of the 6th Annual Research Bazaar. I'm Claudia Solis-Lemus. I'm an assistant professor here at the Wisconsin Institute for Discovery and the Department of Plant Pathology, and I will be moderating this session. I want to remind people of our code of conduct and give one last thank to our planning committee. So thank you. This has been a great couple of days. I hope everybody agrees with that. So thank you all that participating and planning this event. Oh, thank you. Yes. And also thank you to our sponsors. So we have come to the closing panel of the Research Bazaar. Throughout the Bazaar, we have heard from a variety of speakers on different tools and research approaches to artificial intelligence and machine learning. And today, our panelists will share with us their perspectives on current opportunities and boundaries with AI and LL in government, research, education, cybersecurity, and law. Okay, so I'm going to be introducing the panel first with Secretary Kathy Blumenfeld. She's a leader with extensive experience in the financial services industry, business, and government. She was appointed by Governor Tony Evers to lead the Department of Administration in 2022 and previously led the Department of Financial Institutions. As secretary, she is committed to prudent fiscal management of the state's budget, modernizing the state workforce, and improving government services for Wisconsin residents, partners, and state agencies. She also serves on the boards of the State of Wisconsin Investment Board, the Wisconsin Center District, the Wisconsin Economic Development Corporation, and co-chaired the Governor's Task Force on Workforce and Artificial Intelligence. Thank you, Secretary Blumenfeld. Next, we have Rafael Ferreira. He's a researcher associate in the Department of Animal and Dairy Sciences. His research areas include computer vision and machine learning techniques applied to dairy farm management. With a background in electrical and computer engineering, Rafael develops machine learning applications and facilitates early disease detection in dairy cattle. Welcome, Rafael. Okay, next we have BJ Johnson. He is a full-time instructor at Madison College teaching courses on information security, software quality, and AI. BJ demonstrates his decades of research expertise in artificial intelligence by deploying an AI, which BJ researched and developed over the years as a teacher's assistant in some classes. Prior to the college, BJ's experience as a U.S. Marine was utilized as a consultant to the Department of Defense and other large corporations. Thank you, BJ. Next, we have Heather Johnston. She's an IT policy writer and analyst in the UW-Madison Office of Cybersecurity. She has nearly 20 years of experience in higher education on both the academic and administrative sides of the house. In her current role, she is responsible for facilitating development and management of IT policies at UW-Madison. As the holder of an English degree, MA University of Cincinnati, Heather is proud to say that all she really needed to know about technology, she learned in the humanities. Thank you, Heather. Okay, and last but not least, we have Charlie Von Simpson. He teaches at UW-Madison Law Entrepreneurship Clinic, where he supervises students advising inventors, founders of startups, and early-stage companies. Charlie also teaches a course in intellectual property licensing. Prior to joining the UW faculty, Charlie spent 2 years as a legal subject matter expert at a Toronto startup building an AI-driven legal technology platform. Before his legal career, Charlie was a consultant and journalist in the computer industry, including a position as a Silicon Valley correspondent for Computer World. Thank you, Charlie. Okay, so we're going to start with a question that is for the whole panel, and then we're going to move on to specific questions for each of the panelists. So the question for everyone in the panel is, what is one opportunity or boundary with AI or ML that is top of mind for you right now? So I guess we can start with, well, whoever wants to jump in and start, but maybe, yeah.
We can start and go down the line. Hello, everyone, and thank you so much for the opportunity to be here and to participate. I found so many of the sessions, just my head is so full of information right now. I'm sure you're all feeling the same thing. So when I think about our role, I lead the Department of Administration. So we have oversight for technology for 34,000 state employees. So what keeps me up at night sometimes is thinking about AI. It's very exciting. It's moving very fast, and everybody's trying to leverage it in ways. But I think about from a cybersecurity standpoint, like how do we keep things safe? How do we make sure when we deliver things to the public, we want to make sure that we're giving the right information. So how do we do that? How do we do it ethically and with equity, an equity lens as well? So those are some of the things that keep me up at night, and that are very much top of mind. So thanks, Rafael.
So thank you for the opportunity to be here and the introduction. So building up a little bit on what Secretary said, in the lenses of research, I think something that I think about every day is how large language models are becoming scary, and not only in like how much they know or how much they can simulate a human, but also thinking about research and development of algorithms. They have the potential to turn a lot of what we know about machine learning kind of obsolete. So if you think about large language models with multimodal tasks like interpreting images, audio, video, and so on, sometimes pre-trained models that haven't been fine-tuned for any specific tasks are already really good at doing some general work, and that in the past we would have been training specific models for that. So I think the main thing that these large models are bringing is that maybe we change the paradigm of having to train models for specific tasks, and then we're going to have something closer to like a general AI, if that's possible. And one or very few players are going to kind of control these general AIs that know everything, and that's a bit scary. So I think about that fairly often. Yeah. Thank you.
All right. Glad to be here. Had fun. I have to say, I have a kind of selfish look at this. We have barriers. I mean, yesterday there was a lightning talk about training the models, the amount of time it takes. We have companies, Microsoft's one of them. I think Amazon's doing it too. They are actively researching, developing, and attempting to deploy nuclear power plants just to power their data centers. All right, because graphics cards take a lot of power, a lot of cooling. If you've ever built these machines on your own, my lab, all my kids, they had their gaming machines. It was cold until they turned on their computers, and then it was not. We are concerned about the large language models as they exist with our hardware constraints today. What I'm really looking for, I guess I'm excited and terrified at the same time. Quantum machines are ideally suited for this type of processing. I mean, the GPUs, they process large amounts of multi-dimensional vector data. That's what quantum machines do, except you just don't have the same kind of hardware constraints. So the problems that we have, today, trying to, circumvent training issues and optimizing our algorithms so, we can eke out a bit more performance, that stuff changes fundamentally, like encryption, with quantum machines. And we are, Microsoft just they just had a breakthrough, but it's unconfirmed. But that stuff is coming. And yeah, we don't really have a handle on the AI today. And those things are set to throw that through the roof. So that's what I'm thinking about.
So my area is IT policy, and one of the reasons that we have IT policy is to manage risk. And so for AI, that's about putting boundaries around its use so that we can protect the institution and the individuals in it. And one of the things that we can predict is pretty likely to happen with AI inadvertently or even without people realizing it is data loss. So exposure of social security numbers or other personally identifying information. And so what we've been focused on is connecting the dots between existing UW-Madison IT policy and these new uses of AI. So we issued a statement on use of generative AI at UW-Madison that was issued by our Chief Information Security Officer, Jeff Savoy. And it says basically two things. In most cases, university students, faculty, staff, anybody affiliated with the university cannot enter any data that isn't either public or low risk into AI platforms unless they've gone through appropriate approvals. Primarily, that's cybersecurity risk approval, but it can also be accessibility approval. It could be purchasing approval, those kinds of things. And so that's how we are trying to contain those risks. We have a couple of policies that address these risks. One of them is the Regent policy on acceptable use. Another one is the UW system policy on data classification. And then also the university policy on risk management. We also have a number of tools that have already been approved for use. So that's Google Gemini, Microsoft Copilot, WebEx AI Assistant, and Zoom AI Companion. So if you're UW-Madison affiliate, if you sign in with your Net ID, you can go ahead and use those tools without further review. If you need to use something new, be cognizant that you will need to go through that approval process. It can take a little bit of time. And also that the language of the contract that's to be signed will be really important because that has a material impact on the risk that the tool poses.
All right, I'm next. Thanks for having me. This is really a fun group to speak to for the following reason. I think the biggest opportunity and boundary for adoption of AI by people in professional services, lawyers I'll speak to with the most knowledge, but also I think doctors and all sorts of people delivering expert conclusions to their clients or patients or whoever, is really around the issues of explainability and trust. So I think the biggest headwind for lawyers is that we often aren't sure that we can trust the answers that language model systems are generating. And we can't trust it in part because it sometimes seems to behave erratically. And it sometimes is because we don't really understand why it's delivering the answers that it's delivering and whether or not those answers are complete. And I'll give you a sort of unsettling example just quickly. There was a lawyer a year or so ago who handed in a brief to a very significant court in New York City. And it turned out most or all of the cases that were cited in the brief had been hallucinated by the large language model that he used and did not actually exist. And I think he was a very naive early adopter of the technology and could have done some more due diligence on his own part. But the interesting and sort of sad and thing that made me want to hug him was he returned to the court the queries he had used to query, I guess it was ChatGPT that he used. And at one point he said, "Is this really, really accurate what you're showing me? Can I count on this?" And ChatGPT responded, "Oh, yes, of course. These cases are all very well settled and established." So not only was it returning a bad answer, it was very emotionally connecting with its user and convincing that person of the accuracy of the result. And so I think those kinds of issues erode trust. And I know in my experience building an AI system for lawyers, their objection to adoption a lot of the time was not so much around trust, because they were often using it in a closed database where hallucination wasn't really such a big problem. It was around explainability. How do I know when I've exhausted my efforts in this regard? How do I know when I have a complete answer? And how do I know that the answer is being communicated in a way that that makes sense? I along the same lines, outside the experience of law and the practice of law, there's actually a great article in the New York Times today. I just happened to notice it on my way over here, in which there's a group of doctors trying to find existing drugs that can be compounded in new ways to treat rare illnesses. And what really caught my attention was that they're using an AI system to do this. And one of the things the system does is provide ranked lists of combinations they might try, with ranked according, I guess, to the system's confidence that this is a good combination. And the doctors then, though, undergo an enormous amount of work to figure out if they trust the ranking system that the AI has used to recommend the drug combinations, and they really lose the efficiency of this really incredibly powerful tool because they have to go back and check it and experiment and do all sorts of other things. And that struck me as what that is more than anything is an explainability problem, and they don't understand how and why this result is coming to them. So it's really nice for me to speak to this group because I would love it if people started doing some more work and some more really innovation around explainability, particularly. I think that's what users need. And I think as we start to move language model systems from an interesting experiment or an interesting thing to try as a first pass on a problem into real products, which I'll make the argument that there really aren't very many good AI products in the sense that we think of them for users. I think that's really both the big opportunity, enormous opportunity, and also kind of the barrier to adoption. So I'm glad to talk to this group about that issue. So thanks.
Thank you. Thank you all for sharing your perspective on that. So we now have a unique question for each of the panelists, and then we'll have time for panelist discussion. And then after that, we will respond from questions from the audience. So the first question is for Secretary Blumenfeld. Okay. There you go. As DOA Secretary and co-chair of the Governor's Task Force on Workforce and Artificial Intelligence, what practical steps are you taking at the state level to govern AI, to encourage innovation with AI, and to provide training to the workforce?
Great, thank you. So a couple of years ago, we sat down with the governor and our cabinet. We talked about AI and all the things that we needed to do to kind of start thinking about how to address it. And really big issues came up. And our governor always, if we had a nickel for every time he says it, he talks about connecting the dots, that as state agencies, we all need to work together to solve really big problems. So one of the issues that bubbled up towards the beginning was workforce. So both from our internal state workforce, but then as a state, our workforce, how is AI going to impact like the fourth revolution, right? Like we know that AI is going to touch just about every single person in our state. So one of the first things we did was said, let's get together people from all different sectors that are thinking about AI. And the governor created a task force, the governor's task force on workforce and artificial intelligence. And so we got practitioners in AI, we got folks from the university system, from the technical system, from the big IT companies, software companies that were working on it, from the public sector, the private sector, and created this task force to start thinking about the impact on our workforce. And that was eye-opening. In a way, at the beginning, it was like, oh my God, we're boiling the ocean here. How do we sinnow down some practical things that we could recommend to the governor that would help move our state workforce forward? And that was just a fascinating experience, and thinking about it from an equity standpoint, from an economic development standpoint, from workforce training issues, from even like K-12 education. What do we need to be doing now to make sure that the future generations can come and find jobs and do their jobs well and efficient? So we came up with a whole host of recommendations to the governor at the end of the time of the workforce. I'm glad to say that many of those recommendations have been adopted in his budget that he just introduced to the legislature. The legislature also, like we always do, they had their own task force on artificial intelligence, and also came up with a set of recommendations. Many overlapped, which is great. And some more legislation is likely coming forward. So it was a really great exercise. We had recommendations in the workforce, like how do we train new workers, maybe through apprenticeships? How do we take displaced workers or workers that wanted to upskill and help connect them to opportunities in the workforce? We talked about economic development and how do we incent businesses to adapt and kind of like move the needle forward on AI, where they can really become manufacturers of choice or do the jobs that the work that they're doing much more efficiently. We had recommendations in the in higher education, so both for the UW system to be able to collaborate on curriculum and also help support, as Heather mentioned, like on the cybersecurity front and the data side, and even in procurement, thinking about like how do we procure new, right? This is a big issue. Like when you procure something new, how do you have your procurement team and your business teams look at the AI that is embedded in these products and know that it's going to be safe? And then from a government standpoint, one of the recommendations was to create a council within our state government that is going to look at how do we bring in AI to do our government services better. And so we have created an interagency council on artificial intelligence with representatives from the bulk of the state agencies. And as a result of that, we've been putting together, we asked for use cases. I think we got like 300 different use cases for how we can leverage AI. And we've been able to kind of pick some pilots that we're going forward with so that we can kind of all learn together in very safe environments. So it's been a really, it's been a journey, I'll say. And I'm sure wherever you are sitting, wherever you are coming from, your organization is trying to think about these very same things. And so we just kind of want to keep in mind, top of mind, really, like, how do we use AI? How do we govern it? Like I talked about at the very beginning, those things that keep me up at night, right? How do we govern it in a very safe way? How do we educate and train and lift up workers in our state? And then how do we use it to innovate? And I know that's the part that really excites all of us and makes us want to run towards everything. But we also have to do it in a safe and a practical and efficient way. So lots of really good things happening at the state. We do partner with thought leaders, both in the public and private sector. So we all have to work at this together and come at this together. So I'll pause there and turn it over to the next question.
Thank you. The next question is for Rafael. So yesterday you presented a poster on using large language models to extract information from scholarly articles. What led you to using LLMs in your research? What problems were you addressing, and what are continuing opportunities for improvement?
Right. So first, I guess the main motivation was seeing the success that large language models had in other areas. So we've seen a lot of progress in extracting information from free-form text. So that was the main point that we wanted to address in this project. So we're really interested in really exploring the potential for large language models to extract information from text that is written by humans and that would be otherwise difficult to include in quantitative analysis. So giving a more specific examples in our field for dairy farming, it's really common to have farm workers take notes about the cows, like, oh, this certain cow is looking a little low energy or a little weird, or we moved a cow from a pen to another, we gave a certain vaccine to a certain cow. And this information a lot of times is not available in a structured, standardized format. And each farm kind of does it in a different way, and they're usually like free-form text. And a lot of our research is focused on trying to do early detection of diseases in dairy cows. So we want to get all the information we can from a certain cow and try to predict whether that cow is going to be healthy or sick, so we can prevent health problems with that cow instead of just like treating it after it already happened. So that was the main focus of our research. So we figured, okay, now that these types of language models are so successful in extracting information from text and even interacting with users, how about we use them to really unveil the potential for these freeform text that the farm workers have been taking account of in the farm, and then use that for trying to assess disease incidence in farms. So that's what led us to start this project of, okay, let's get all of this freeform text that's available, and then we use those language models to essentially kind of convert this text into numbers. And this numerical representation of the text holds information about the context and semantics of that text. So we're really wanting to see whether those models could understand what's in the text and extract information that can be useful for disease detection and prediction. And then we found that, so we tried two main approaches, which is one using just a generic model that is available online. You can just, it was trained in like a lot of text on the internet on everything, and see if we can fine tune those kind of models for our specific domain. So I guess that was the main like motivation of doing this, was that if the models know about dairy farming, they were probably going to be able to extract better or more relevant information from the text than a model that is super generic. So there's some terms and some jargons inside of there, or like some types of vaccines that a generic model wouldn't know, but maybe a fine-tuned model would. So we trained a model using papers from Journal of Dairy Science, trying to kind of teach these large models all about dairy science. So it's like we're having a new student joining our lab and like, okay, now you need to learn about cows. And that's all 1,000 papers from last year. Just read all of them and get all that you can from it. And then we are comparing whether those models were more successful in extracting information from the data. And we found that they were. So they're slightly better, but it's still like significant enough that was really interesting and really promising. But for this preliminary project, we only did it with papers from 1 year, and that was already a lot of computational power. So what VG said about those training those models requiring so much computational power, that's our constraint at the time. We only have hardware to train in 1 full year of papers. But now the next steps would be to try and do with more data and maybe filter out certain keywords that are specifically related to the disease that we're trying to predict. And I guess that's the main challenge now. I guess the computational power to train those models and really fine-tuning those models and what the potential for that is, what the limitations are, and how far you can go. And then just a final concern as well that we haven't tackled yet, but it's in the back of our minds too, is how do we deal with copyrights, right? Because those papers were written by authors, they were published by someone, and the data there belongs to someone. And then when this data is given to those models, like who owns it now? And when the model paraphrases certain information that you read from those papers, who owns that response from the model? So it's a paraphrase, but it's kind of copied or heavily inspired from the data set. So it's still like an ongoing discussion. We don't have an answer for that yet, but it's a very interesting one and very relevant for our research. So, yeah, thank you.
Thank you, Rafael. The next question is for BG. Sorry, BG. I'm changing your name. BG, as an experienced computer science instructor, what do you think is missing in our education infrastructure related to the use and abuse of AI in practice?
Next slide. So move fast and break things. That's really been the mantra that has been driving software development for quite some time now. We do move fast, and from certain perspectives, you could say that, yeah, we broke society. One thing that I try to have my students in my class do is to try and evaluate what you're doing today. Try to find, let's look at what that equilibrium of altruism, liberty, altruism, and justice. What does that look like for the applications I'm building right now? How does that change over time? Who does it impact? Those are the kind of questions that I try to get them to wrap their heads around. I don't have a whole lot of students in my classes because it's hard to get this point across to them. But nevertheless, it is an important thing to consider. So that diagram is just an output or a representation of output of an algorithm that we are running inside of the class. The whole point is to try and keep that equilibrium equal across those forces. Depending on what you're doing, that thing could actually, the marker for it could shift depending on perspective and scenario. Consider 10 years ago, I could have written an application for, let's say, like immigrant day laborers, right? So instead of stacking in the back of a Home Depot parking lot or a Lowe's parking lot, we could have had an app set up where they could have registered. The business owner could register. Hey, we need 12 day laborers here. This is how much we're paying. I'm going to be in the parking lot at 7:10. I need 14 people. And that application I could have looked at and thought, all right, I have the liberty to do so. I see we're helping out these people. I don't really see too much of a justice impact. Everything looks good. That application today would be an iced honeypot. I mean, that's what it would be. That's a dangerous tool now. If you were to talk about, about 10 years ago, menstrual cycle trackers. I think my daughter was looking at something then, and I saw the app. She had it on the phone, because she was learning. And I looked at it and I said, well, I don't know. You're going to have to put a lot of stuff in here, and there's just one little author, and I can't even pronounce their name. I said, I don't like this app, Kylie. You're just going to have to do it the hard way. Do what Mom did. And so she let the thing go. That kind of an app today, depending on where you are in this country, is a liability for the data, the people supplying that data. That changes. So the equilibrium of how that app fit 10 years ago versus the way it looks today could shift completely. We just need a bit more thought on this. Social media. Next slide. Social media, you have Facebook. So I want to say something. Facebook as an app, as a platform, as a system works. It just does. 30 years ago when that thing came out, it was exclusive. It was only open to Ivy League students at colleges at the time. We all clamored to get access to that tool. We all did. We thought it was a great idea. To be honest with you, the application business model works fairly well. I mean, they're not into content creation. We put the stuff inside of there that they're going to project out, and they don't really control what we want either. They have algorithms that feed us the things that we want to see. And let's be honest. I mean, a lot of people don't necessarily want to see a bunch of kittens and puppies skipping rope in a field chasing butterflies. But if you were to give them a video of a house being burned away by a lava flow, they're down with that. So we actually kind of consume the things that we want to see, and that tool gives it to us. It's what it does. So You have in 2020, the companies called on the carpet to Congress. We want you to explain why privacy has failed so much with you. Your monopolistic tendencies, and of course, we want to understand this political bias that we find inside of your systems as well. 2024, you have a new batch of corporate leaders. Notice that the Meta Facebook one is still still in the picture. There he is. He's in both of them. 2024, we want to understand what's happened to our children. We don't really understand. Every time they use your application, think bad things are happening. We want to know what your algorithms are doing. We want to know why have you built addictive algorithms into your tools when you know our children are going to fall for it. All right. So you have that kind of thing there. We don't really understand truly the impact of what social media has had. That big technology shift. We have scientists over the past few years have said that be careful with our AI. It's like a Swiss Army knife. You put that in the hands of a wrong person and you could stab someone. Just recently, a group of nations decided we're going to take some of that guidance and we're going to create a pledge to follow the guidance and put some responsible guidelines for the deployment of AI. There was an even smaller subset of nations that decided, the hell with that, we're going to go full force into AI. And that would be our current president of the United States with his executive order effectively wiping out the federal guidelines that we had, the fledgling guidelines that we were trying to put into place for AI development. And then, of course, you have the double whammy down below of the $500 billion investments in the Stargate project with, who is this? OpenAI, Oracle, and SoftBank all looking to rake in billions. Now, what I was about to say is we can't afford to have another batch of corporate leaders sitting in front of Congress and, Congress demanding, where did our jobs go? Why are your AI running amok? Why can't our children think anymore? It's probably too late at that point for us to do anything about it because we would have normalized having the machines do our thinking for us. I was about to say before I came in today, we can't trust our leaders to safeguard our best interests. But my colleague and I talked with the secretary here at lunchtime, and I had to amend what I was about to say because I like you. I like where you're going. And so I am going to say we have the power as leaders now in this space to help our leaders do the right thing for our people. Think about what we're actually doing today, the impact it's going to have on tomorrow, and the impact it's going to have for our children. We have that ability to do that ourselves.
Thank you. Okay, our next question is for Heather. AI is moving fast, and it may be a while before we see robust AI-specific cybersecurity policies. What can we do to reduce information security risks in the meantime?
The first thing I would say is just kind of to repeat what I said in the first question, which is that we don't really have to have AI-specific policies or policies that specifically address AI to know what to do. We have existing policies that can give us guidance. So again, I'll just mention as examples, the University of Wisconsin system data classification policy and the University of Wisconsin-Madison cybersecurity risk management policy. So those things both have relevance to AI. And then to kind of build on what VG was saying and also what Charlie was saying earlier, one of the things that we have to do is to remember that AI is just a tool. It might sound human, it might try to make emotional connections with us, but it really isn't. And so that tool is only as effective as the choices of the humans that are using it. So, without human judgment and discernment, AI can be benignly useless or malignantly harmful. And it's just like if you had a hammer, you're not just going to point a hammer at a picture and expect the hammer to hang it magically on the wall exactly where you want it. If you're going to use that hammer to repair a window, you're only going to do that after you acknowledge its potential for destruction. You have to recognize that you're making a choice. It's a considered choice, and you've decided that it's the best tool for the job, even though it comes with risks. And so it's the same with AI. You can't just point it at a problem and take what it gives you and copy and paste it into your brief to the court without thinking through, what it said. And also, if you're going to use it on anything breakable, you know that you need to do that with extreme deliberation and care. So kind of to make that a little bit more practical, we can do two things. One is we can always use a human reviewer, and the other is that we can maintain our basic skills as kind of a check on AI. So again, we all recognize at this point, I think, that AI hallucinates. And it can be very confident and authoritative. At the same time, it is very, very wrong. And this is why, for instance, the CISO statement on AI that I mentioned earlier, one of the things that specifically prohibits is using AI-generated code for institutional systems and services without review by a human to make sure that there are no malicious elements in that code. Another reason that we need human reviewers is that AI is biased. There are lots of biases. There are some structural issues that kind of underpin this, but also, anybody who's used a search engine can pretty much guess that a tool trained on the entire content of the internet could handle things inappropriately. So AI doesn't have morality. It doesn't have empathy. It can't distinguish one thing from another. So we need human morality and empathy to judge the content and handle it appropriately. We need to keep our skills sharp because we need to recognize when AI misbehaves. So we need to understand how things work in order to catch small things before they become big things that get reabsorbed into the AI. So, it's hard to catch malicious code in a human review of AI-generated code if you don't know how to code in the first place. If we're talking about like radiological images, if you don't know how to read an X-ray, you're probably not going to catch it when AI makes an incorrect diagnosis. So we need to keep those skills up. And also we need to be able to correct AI's errors. So we need to recognize when it makes an error. We also need to be able to correct that error. So it's new technology. It's going to change. It may become more reliable, but right now, one of the most consistent things about it is that it is unreliable. So we need to know how to compensate, and that requires basic skills. So if we think back to maybe when cars were new technology, you can imagine that everybody who's tooling around in a car probably needed to know something about how to fix it because they probably broke down a lot. And unless you want to get stuck on the side of the road, you're going to need to know how to jump in and do some basic repairs. So it's kind of the same thing. That's where we are with AI right now. It's that new technology, and it just isn't mature enough yet, if ever, to let us step out of the loop. So let's see. Practical tips for data scientists. You can be mindful about the data collection. You can tell your subjects how you are using the data that you collect. Make sure you get their permission. And then next, that's the right slide. So then if you're building your own AI or LLM, you can use the National Institute of Standards and Technology, or NIST, building blocks for trustworthy and responsible AI. So there are 7 of those. In terms of validity and reliability, you can build in safeguards for integrity. You can develop a process to monitor and address any errors that come up. You might also consider running your AI locally to ensure repeatability. In terms of safety, you can put safeguards in place to minimize misuse. For security and resiliency, you can put guardrails for data access. Make sure that you're reviewing your access controls regularly to make sure that only the people who should have access do have access. Accountability and transparency. You can be transparent about the source of your training data. Explainability and interpretability. You can explain clearly how your AI is making its decisions. That's, again, what Charlie was mentioning earlier. Privacy. Use data only for the purpose that you said you would use it. And also don't kind of let the quest for lots and lots of training data to make you kind of blind to the privacy concerns. Fairness and mitigation of harmful bias. Make sure that the AI decision-making is unbiased. And if you see imbalances in training data, make sure that those get addressed. If you're using existing AI, be mindful of the data inputs and outputs. Any data that you're putting into the AI, make sure you understand the data classification and how you protect the data based on that classification. In terms of outputs, you need to consider what data the AI model was trained on. What's it relying on? Is that data validated? Is it biased? And what you should do to mitigate those things. And then be transparent about the AI outputs behind your work. So this is a little bit about what Rafael was saying about copyright. Also, aside from the issues of copyright, we need to be transparent about what's kind of informing our work, what inputs we're using. And then last thing I will say is if you are aware that there is any AI-related data exposure, you need to know how to report that. So for UW-Madison, you would call the Do It Help Desk. That's 608-264-HELP. So if you're aware of any of that data exposure, call that. We also have an incident reporting and response procedure. That's part of the UW 509 policy set, and you can learn more information there. Okay.
Well, thank you to a couple of my colleagues here for introducing my subject. I think the most important issue in intellectual property and AI is how we balance the interests of intellectual property owners, so content creators, against those who want to use it to build and test algorithms, and how we decide what is and what is not copyright infringement as that process unfolds. Now, I think the one sort of step back thing I'll say is that all intellectual property law, patent, trademark, copyright, and associated law is all about a balance between the intellectual property owners, who are people who have developed rights in content or in inventions. We give them a limited monopoly under the law in order for them to give them an incentive to invent things and to write things. And we recognize, though, that we want to put a limitation around that ownership to encourage other people to adopt their work to advance society and increase the wealth of everyone, the economic wealth and the intellectual wealth of everyone. And that's where we are right now. That's the fight that we're in the middle of at the moment. I think what's up on the screen is the complaint filed by the New York Times against OpenAI and OpenAI entities and Microsoft, alleging that the way OpenAI trains algorithms and collects data infringes the New York Times copyright in New York Times journalism. This suit was filed in December 2023 and has not really advanced very far for a couple of reasons. But one of them is there's been a whole raft of other similar lawsuits that have been consolidated. Various stakeholders have sued OpenAI, have sued Anthropic, have sued really at this point anybody who's doing any kind of AI application, making basically the same arguments. The comedian Sarah Silverman, it turns out, is a very aggressive litigant in these cases and is a plaintiff in several of them. Fundamentally, the argument is by the Times is that when OpenAI goes out and gathers data in its giant data vacuum, one of the things it has taken with real vigor and enthusiasm are New York Times articles. The Times alleges that that OpenAI has ingested over 1 million New York Times articles in the process of creating the OpenAI platform and application. And it's a particularly pernicious type of data use from the Times' standpoint, because once you start talking about generative AI, you're not just talking about identifying parameters or tokenization or those kinds of essential data functions. The systems, by their design, take the Times content and essentially regurgitate it into new content, but often the verbatim or pretty close to verbatim reproduction of what had been in the original Times article. And again, for everyone who is a plaintiff in one of these lawsuits who's brought the same claims, the allegation is essentially the same, which is once you start reproducing content based on my work, and in many cases the content you produce is either identical to or similar to mine, you're infringing my copyright in the use. And that generative AI is functionally different than a Google search, which returns links to other content, returns links to my content, which may have a paywall around it. Now you're taking it and generating new content, which effectively replaces the demand for my newspaper articles. So if you're going to go to the next slide, I think it just summarizes quickly. So the Times alleges that OpenAI scraped millions of Times articles, that ChatGPT reproduces Times content, and that it gives people alternative access to Times articles. The Times point here, from an equitable standpoint, which I think is fair, is to say, look, we send journalists around the world, often at the risk of their lives and at an enormous expense, to create this content that you're essentially a free rider on. And your use of the content weakens demand for the New York Times because it's something that people can get for free, it's easy to access, and to some degree replaces the original reporting that we have done. And then next slide. OpenAI argues that it may be infringing your copyright. Now, there's some arguments. OpenAI obviously doesn't concede that it's infringing the Times' copyright. It has a bunch of arguments around why it may not be. But fundamentally, and I think this is where these issues will be decided, is under what's called the doctrine of fair use. And fair use doctrine says, okay, you may have a copyright, and my actions may be infringing the copyright, but we as a society have decided that there are circumstances in which we want to allow a copyright infringer to go forward without penalty, essentially a defense to copyright infringement. And one of the core qualities of fair use is if the infringer, the person who would otherwise be an infringer, if their work transforms the original data into something new, that's something that we want to encourage. And there's been a lot of litigation over that over the years about what constitutes fair use. It is not an easy application, or it's not an easy legal doctrine to either explain or adopt by judges to decide these disputes. I mean, fair use is something in a copyright class that takes about a month to explain, and the students all look a little glazed over at the end of it anyway, so I'm summarizing it for you in 30 seconds. But the fair use doctrine is an enormously important way we regulate the economic activity of intellectual property holders and the competing interests of people who want to use their IP. So OpenAI's position is it's this transformative fair use, and it's not copyright infringement. And by the way, it's not really going to be a substitute for the New York Times because they're just different things. They have different audiences, and one's not a substitute for the other. I find that the latter argument pretty unsatisfying and unconvincing. I think at some point, clearly it is and does do market harm to the Times, and I think it's hard to argue. I think it's hard to argue otherwise with a straight face. I think the other part of the fair use, this transformative fair use argument, is probably a better one. I think that's all I wanted. I think that's all I wanted to say about that. The thing I will say is now you have, I think, at least a dozen lawsuits and maybe close to 20 at this point. I sort of lost count around this issue of infringement and fair use. And the problem with the way the law develops in general, and it is particularly acute in this circumstance, is that these cases will settle. Because the New York Times doesn't really want to litigate against OpenAI for the rest of time. And I think if the parties are bargaining rationally, and we always remind ourselves that every case that goes to trial in a civil case is the failure of one party to bargain rationally. But if they do bargain rationally, they'll come up with agreements. And the good news is that will be an efficient way to resolve these cases. The problem is we won't know how they resolve them because their settlements will be confidential. And so the law, I think, will evolve very slowly. And I think certainty around who exactly owns what will take some time to develop.
Okay, thank you. That concludes our section with specific questions from the panelists. And now we're going to move on to the Q&A from the audience. So is there anyone, and we have a microphone here so that people can hear you also once in Zoom.
Hi, my question has to do with I'm concerned as a customer, I might be in the very near future be subjected to decisions that are AI generated, and I don't know that there is a lot of transparency in that. Can you talk a little bit about how that could be improved and what kind of protections may I have in the future as a customer if I'm impacted by a decision that I don't like?
I'll start. I mean, the answer, of course, is you already are subjected to probably a lot of decisions that are driven by AI, as we all are. And I think we all share your concern that it's sort of a black box, and how do we know whether this is being fairly applied? And unlike other things that we are subjected to, there's very little transparency around how these things are built, or you all know more than anybody else in society about how these things are built. But even among scientists, how they're applied. I think the problem is, and BG was really touching on this, is that there's no good regulation of it. And I think given the current political climate in this country, there will not be any good regulation of it anytime soon. Europe is way ahead of us. The European Union, the European Commission has enacted a lot of laws that are much further down the road in terms of consumer protection around AI. And I think that provides a good model for where we might go.
I can just add a little to that. Is probably that's why we're moving so slowly in state government, is just we don't want to deliver the wrong answer. So trying to develop policies, try to develop transparency where we can. And also to Heather's point, to have a human involved is really important for us right now, so that we're not just delivering information. And then with most government units, there is an appeal process. And so if you are delivered an answer that you have the opportunity through some mechanisms, and also in the legal system, that there is an appeal process to be able to work through. So, but transparency is one of the guiding posts that we're using as we develop our protocol and approach to this.
Thank you for the panel. It's really interesting. I have a question kind of about two competing harms that I see happening right now. One is, and I'm especially glad you're here, Secretary, I work with foster care systems and child welfare systems across the country. And I'm seeing two things happen at the same time. Those systems, those computer systems with the data, are so old and so obsolete. They're behind education, they're behind healthcare, they're behind everybody. And I work with social workers who spend hours every day typing things in. So they're being left behind, and that chasm is growing between the cutting edge of technology and what people are spending all day doing. At the same time, there are private enterprises coming in with solutions, AI-driven solutions. And I'll give a good example of this. There's a new company that does training and fidelity monitoring for clinical interventions. Like motivational interviewing is a good example that gives change talk to a client who's trying to address, let's say, substance abuse. And whereas before human beings would train and check on fidelity of the practitioners, now it's fully AI. So I work with policymakers who are saying, okay, the human trainers are this much, the software is this much. Software, do they know anything about outcomes, fidelity, reliability, safety? No. So I'm seeing two types of harm: people being left behind, but also people having solutions put in front of them without any context or information. So I'd love to hear you speak to those kind of competing harms at the same time. Long questions.
I'll just say, I think you're spot on. So, I know at the state we have hundreds, if not thousands, of different programs. So modernizing them is a big focus for our administration. And during COVID, we saw our unemployment, our unemployment insurance system just, collapse because it was a 1970s green screen program. We were able to bring Google in and use AI to use artificial intelligence to do adjudication, which got us out of that while we were rebuilding a new system. So at the state, what we are trying to do is look at every piece of software that we have, look at it from high, medium, and low priority in terms of impact to our citizens and the people that living and working in our state, and trying to modernize as we go. Along with that, there are always going to be new entrants into the software realm. And I think we just have to figure out how to create public-private partnerships to leverage the new while kind of modernizing the infrastructure that we have as a state. And that's hard. But that's our commitment, is to really look at and modernize and leverage while we're putting in all the safety guardrails that Heather talked about. Like we just rolled out our first acceptable use policy throughout our enterprise. We're standing up an AI office as well as a data privacy office, because each state agency holds data and we're not good at sharing, which, is probably good in some ways, but it doesn't enable our ability to like connect the dots and solve problems. So there's a lot of forces that are happening all at the same time, but hopefully with that, we're moving forward as a state, and that is our goal in terms of modernization and transformation.
Yeah, and I'll just say too, I think that is a little bit about what I was saying about keeping your basic skills up. So like you have to, the humans aren't having the opportunity at that point to keep their basic skills up because the tools that they're given are kind of behind. So I guess that just speaks to it being maybe not a personal choice issue as much as it is a systemic issue as well.
Hi, I'd like to speak to the phenomenon of sort of the power of the infrastructure going to a small number of companies. And like you mentioned, public-private partnerships, but again, the opportunities always seem to flow to a handful of large abusive companies. And so I was curious if you could speak to, do you have ideas for ways that there could be more opportunities for either local companies or even universities to be able to develop their own capabilities and not cede all of their capabilities to a handful of companies?
I just saw an article, I guess maybe yesterday morning, and the question was asked, where are the open source, the true open source AI models? Where do they exist? Not the Meta Llama, not even DeepSeek. True, with the inference engines, the models themselves, all supporting software. And the reality is, these things only really work with data. And you have to be able to capture a lot of data. And that requires a lot of money. And even with that, that money, a lot of that, as was mentioned yesterday during one of the lightning talks, is a lot of human assets required for additional training. So the true open source alternatives that we would want to see today isn't really financially viable yet. We don't really have the means to truly automate a lot of the training, data collection. Yeah, we automate data collection, but that has to be cleaned, it has to be processed, it has to be prepared. And unless there are revenue generating sources for open source communities to pull that off, it'll be a bit before we see something like that move into their space. That's what I'm seeing right now.
I'll just add that we do try to collaborate too. So this morning's presentation on geospatial AI knowledge discovery talked about the partnership between the Department of Health Services and the UW trying to work together. So where we can, we absolutely try to at least leverage our Wisconsin institutions to help us be thought partners.
I just add something real quick. Also, from a research perspective, it's really important, and we really see a lot of discussion on the importance of making data sets public. So having all the data sets that you use for your research and the code that you use for your research become public, not only so that other groups could replicate what you worked on, but also that it's more transparent what you've developed. So a lot of times, also, of course, when writing the research papers, you have to give as much details as possible. But when you turn those data set public, you expand the capabilities of what your work can impact.
As a data librarian, I like that answer.
And following up on that, we often use, Michael Ferris here at WID, we often use AI to do hard things that we have difficulty doing otherwise. And so if you think of a thought experiment that now within a financial market, everybody then decides to go away and use an AI tool to bid or to buy and sell within that financial market, then there's the opportunity that everybody, because we're trained on the same corpus, as Rafael would tell us is a good thing, because we're all trained on the same corpus, we will all do the same thing. And so this can lead to cases, as we have seen, where the price of a certain asset goes up, or it could lead, or is a good thing for a few people with power, or it could lead to a bad thing where we have a crash in the market. My question is, are there policies or other things that the panel could see that could actually help mitigate these problems, or what should we do about this? I'll just start by saying I think the biggest thing is that there is an incentive in the financial services, in the trading business, to be counterintuitive, because what hedge funds are based on is basically saying, I see a trade other people don't see. So I think the good news is there's a big market incentive to the extent you're going to build automated tools, to have them trained in a way that they don't do what all the other automated tools do. And so I think that's a good countervailing effect, that it does sometimes. All market functions have a follow-on where the smart money starts to do everything and then the dumb money follows and does the same thing. But I think that I think the fail-safe against this scenario of kind of common collective action driving up or down prices is there's a real market function to avoid that. There's a real market incentive to avoid it. I would say that the only policy would be a completely regressive tax code, which I think is well underway. So,
thank you. I know you have, for example, private open source, private models, hosted models, for example, for OpenAI, Anthropic, and so on. On the hand, you have like Hugging Face with full of open source models, usually smaller, but even so, it's large language models. How do you see, how to decide on going for one or other? I know, for example, OpenAI will pay for the model usage and also for the computation resources they provide. But yeah, just like to know your thoughts about it.
I could talk a little bit about that. What we do in our lab, we usually start from one of the options, and it's usually like the OpenAI APIs, because they're just like easier to implement, and we can have an idea of what we are trying to achieve is possible. And then once we want to scale that up, we tend to migrate to more open source models because of mostly the cost and also because of transparency. We have more control of what they do, and we can customize them to our own needs. So that's usually what we do in our research. So depending on the scale that you need your application or the scale of the research that you're doing, using OpenAI APIs are not feasible financially. So we tend to kind of start with that on a prototype and then move to open source models for more longevity and scalability.
Submodels, I guess, when I do my research, so a lot of the stuff that I'm doing, I do locally. So it's not in it's not on large server class systems. Maybe it's server class, but nothing like an institution base. The different models are built different ways. They are different sized, and they can be quantized or kind of diminished in a way. The problem that you run into if you were to diminish them is that you lose fidelity in how accurate or how well they work. But the loss of fidelity means you can actually run it on more types of hardware. So there are things that, I mean, I can get it to run on most of these machines in this RUM. So, I mean, that's one of the ways I look at those models out there. Let's specifically on Hugging Face, the ones that I could quantize down versus the ones that are going to require, $10,000 GPUs.
We're very excited about LLMs right now, it seems, but I'm wondering if you could just hypothesize or think of anything that might happen to just cause us to turn away from LLMs. Let's say in 10 years that the whole thing is just a bubble. Is that even possible? Weird question.
Well, so I'm considered classical AI, right? So a lot of my stuff is based upon a programming language I wrote years ago, made it to an ontology of common sense knowledge. So I use neural networks. My AI don't operate in the same way that these large language models work. It can be said, and it's been, it's been suggested that the things just guess currently. I mean, that's the best that they really can do. It's not completely accurate, but that's the general gist of it. Going away from LLMs, I would see them evolving. Okay, so where the LLMs use, it's simplistic, but while they could use statistical models to, generate the things that they do, the older AI technologies, like mine, use semantic logic for everything. It's just much, much slower. If you could take something like that and merge that with an LLM, it's something that, I've considered doing in my own class. I mean, it's fine with my AI doing what it does, but it's kind of slow. It grades my work and tracks my students. It runs that algorithm that you saw up there. That was just one of them. Their algorithms built in there to help my students understand morality for all intents and purposes. And if I were to use an LLM in conjunction with that, it opens up that possibility for, a great more things. So the LLMs are good at generating. My AI are not. So I could see an evolution of technology, not so much going away from them, but these things would evolve into something else. And most probably a merging of all of these various tools. I mean, we call it multimodal models today.
I'll just say, I don't think it's a bubble. But it is going to start acting in ways we don't like. I mean, AI is going to get out of the box. And I think the big concern is more the King Midas problem is, he wished everything he touched turned to gold, and then his food turned to gold, and his daughter turned to gold, and that wasn't so good. And I think AI, there's no question that it's going to do things that really are troublesome for us as a society. I'll make a plug. There's a great professor, I think he's at Cambridge, named Nick Bostrom. I'm not sure where he is, but he thinks a lot about this stuff. And he's done some great TED Talks about what happens when we build AI that's smarter than we are. And he does some interesting thought experiments that are kind of scary, but I think that's the issue. Will we run from our lives from the bots?
Yeah, and I think I agree with those point of views. And I think if we think about how computer vision was kind of a bubble a few years ago, about 10 years ago, when like the large deep learning models started coming to surface, and we still use them, but they are way more robust now. We have more transparency. We know how they work better. We have more tools being developed to really understand what they're doing. And I think with large language models, it might navigate to that point too, at least in the short or medium term. It's hard to guess what's going to happen in the very long term, but I think that's the natural next step for large language models, being more interpretable and more transparent in what they're doing.
If I'm allowed to also plug in something, I didn't introduce myself a lot. I work in AI on biomedical applications, and I have seen that, going back to your question, if we could move forward, there's a lot of emphasis on protein design that we want to use LLMs, and it seems like there's a lot of work and development on that area, but none of them have actually made the jump, into having something, as Charlie was saying first. So I think that there's a way, I feel that we're kind of like framing the problem into LLMs in a way that perhaps there's a side path that is still missing that I think that someone's going to come up with later. So I will have to echo what BG was saying. I see more of an evolution if we're thinking forward. So sorry that I just plugged in. I'm not in the panel.
So I have a quick question building on this conversation. And Heather, you brought up basic skills that are needed. So, and Claudia, you're bringing up like there's a gap that we need. So in the workforce, in research, in education, in law, in cybersecurity, what are some of the basic skills that we as humans should be developing, or that you're seeing lack a gap in, so that maybe we can be developing alongside of these LLMs developing?
I'll just start by the ability to know your field and know it in depth, to be able to look at citations to make sure that things are accurate that are coming out of these models, and to be curious and to question. Like, I think those are basic traits that are just so important, and we have to keep exercising, right? Like, if we just keep relying on the output and never questioning and never checking or making sure. I love the explainability piece that was talked about, like practicing the explaining of how models arrive at things so that people build that trust. Those are the human skills that are going to be so important to utilizing and leverage the power of AI in a good way. So
if anyone was here for that, Heather Shimon led that werewolf. Is that what that was called?
Margaret led it, but yeah, AI werewolf. Yeah,
AI werewolf. Those skills, being able to verify and validate what simply isn't real. We need those skills badly, very badly. I mean, because there were the little pictures she showed of wolves in sheep's clothing. Yeah, there was one that obviously looked like a picture, but it's hard. So in the security classes that I teach at the college, we talk about this all the time, deep fakes. That is exceedingly difficult to counter, very. And then the problems, especially with deep fakes, is let's say there is something that's been released. It's not real. It would take somebody with significant resources and skills to identify that it's not real. But by the time they finally come out to say that, yes, this was fake, it's already had its impact. It's already out. It's already done. They've won. So those kinds of skills to be able to figure this out quickly, I see that for us humans.
This just goes squarely to one of the things I'm super interested in, so I'll take a minute to talk about it. I think as educators, it has to be more about multidisciplinary education. I mean, lawyers ought to be in the same room with data scientists and people building biomedical applications, so that we all speak the same language and understand each other and can learn from each other. And that doesn't happen. I don't know why. I mean, we are just bad at it. And I don't think it's just this university. I think people's incentives are different and their funding is different and whatever. But if you suggest to, and I love my dean of the law school, he's a wonderful guy, but if you suggest to him, we ought to have a class with law students and data scientists, he'll just say, yeah, I'm not doing that. It seems like a big pain in the neck and I'm not doing it. So I think until we do that, we're going to have a hard time evolving in terms of our understanding of how this stuff works.
I'd like to push back a little bit on always having simple models. So if you think about separation, so you could think about separating some crosses from some circles, which are separated, and people online can't see me drawing the line between the crosses and the circles. You can separate that very easily with a straight line. So everybody would say that's an easy problem, a nice model, simple model. Now, if you put all the crosses within a circle and all of the minuses outside of the circle, that's not linearly separable. That's not a hard problem. The mathematicians would tell you just move into a different space and you can separate in that different space. And so to some extent, neural networks with multiple layers give us a formal way of doing that. But that multiple layer leads to complications in the model. But and harder to explain because you have to move into a higher dimensional space and then you linearly separate in that higher dimensional space. But that's not to say that this is not underlying a good model or a good outcome for from an AI technique which finds this automatically. We don't always have to have just a simple linear separator. We can have much more complicated models, and that would still be validated. It's going to be harder to explain. I understand that, but we just have to work at techniques for doing that, I think.
Yeah, I'll just say on the subject of explainability, there's different kinds of explainability. And you raised the interesting question about explaining the algorithmic functions to non-mathematicians or computer scientists, which in my case, you would have a hard time explaining that to me. But I don't know how my iPhone works, but I can give you a pretty good opinion about whether it's working the way I want it to or not. And I can explain to you what its benefits and what its drawbacks are. And so I think that there are different kinds of explainability that will matter to different audiences. But I think you don't necessarily have to know the most complex inner workings of the algorithm in order to be explainable in terms of the efficacy to a professional or to a user. That's, I hope, anyway. Because if you have to explain the algorithm, I think it's going to be a hard go.
Yeah, I'll jump in on that too. It's kind of like the analogy that I was using about the car. Like, back in the day, you probably needed to know how to fix your own car. Well, now you don't, but you sure want your mechanic to, right? So you want your mechanic not just to know how to use the tool, but how the actual car works. And so I think, again, different levels of explainability. It needs to be explainable to somebody. It doesn't need to be explainable to me.
Well, thank you so much. So with this, for the sake of time, we are wrapping up now our closing panel and our 2025 Research Bazaar. So let's thank our panelists one more time. And also want to thank everybody for attending here. And I hope that the Research Bazaar was good to spark conversations and collaborations that could extend beyond this current event. So thank you all for being here.